Okay, in this video, we're going to look at an application of calculus to study kinematics. In particular, we're going to look at the motion of an object in a straight line. In this case, we're going to assume it's along the x-axis. So if motion is in straight line, we call this a one-dimensional motion. Now, so if the position is given by x, we're going to assume that x is in meters. Then the velocity can be obtained by differentiating the function x, and so it's going to be given by dx dt, and so the velocity is going to be in meters per second. And then from there we can differentiate the velocity, and that's going to give us the acceleration, and so the acceleration is going to be in meters per second squared. All right, so that's pretty straightforward. Now let's look at an example. So suppose we've got an object that moves in a straight line, so that its distance is given by 2t cubed minus 12t squared plus 27, where t is time in seconds. So imagine we want to find a formula for the velocity of this particle. We want to find a formula for the acceleration, and then in B we want to find the velocity and acceleration at these given times. So let's start off with A. So we're going to want to find a formula for the velocity and the acceleration. All right, so the displacement x is given by 2t cubed minus 12t squared plus 27. So the velocity, we can find that by simply differentiating x with respect to t. So derivative of 2t cubed is going to be 6t squared. Derivative of 12t squared is going to be 24t. And so this is going to be the formula that gives us the velocity of this particle through its motion. Then the acceleration we can find by differentiating the velocity. So in this case it's going to be 12t minus 24. So that sorts out question A. Then in question B, part 1, we want the velocity after 0 seconds. So this is going to be the initial velocity. So after 0 seconds, if we just plug in 0 into this formula here, we can see that that is going to be 6 times 0 minus 24 times 0. So that means the initial velocity of this object is going to be 0. So this object starts off from rest. Then the initial acceleration is going to be 12 times 0 minus 24. So this is going to be negative 24 meters per second. So that means as the object starts off, the acceleration is going to be negative 24. Now then after 1 second, so we're going to do the same calculation. So v1, so we're just going to plug in t is 1 here. It's going to be 6 minus 24. So that means after 1 second, the velocity of this object is going to be negative 18 seconds. Okay, then the acceleration on the other hand after 1 second is going to be 12 minus 24, so it's going to be negative 12 meters per second squared. Then in part 3 we want the velocity and acceleration after 5 seconds. So this time we're going to plug in 5. T is 5 into this formula. T is 5 into that formula. The velocity formula, that's going to give us 6 times 5 squared minus 24 times 5. This gives us 30 meters per second. So this time the velocity is going to be positive. It was negative there. Acceleration on the other hand of a when t is 5, it's going to be 60 minus 24, going to be 36 meters per second. So that is part B. We're now going to go to part C. In part C, it says, when is the object instantaneously at rest? Okay, so the object is going to be at rest whenever the velocity is 0. Okay, so whenever the velocity is 0, that means the object is instantaneously not moving. So what we're going to do is we're going to take this formula for the velocity, equate it to 0, and solve. So I've got 6t squared minus 24t. We equate this to 0. Now we're going to notice that 6t is the common factor here. So this tells us that either 6t is 0 or t minus 4 is 0. So this one gives us 0 seconds. This one gives us t is equal to 4 seconds. This first one, we were already sort of aware of that, even though when we did it we were not thinking about this, because we've already seen that at 0 seconds the velocity is 0. So this is where we said this particle starts off from rest. So, and then this calculation is telling us that at 4 seconds again the particle is going to be at rest instantaneously. Okay, then in part D, the question is wants us to determine when the object is moving to the right or to the left. Now the direction of the movement of an object is determined by the sign of the velocity, determined by the sign of the velocity. So if the velocity is positive, the object is moving to the right or up, depending on whether we choose the line to be horizontal or vertical. If the velocity is negative, then the object is moving down or to the left. So if the positive velocity implies movement to the right or up, movement upwards. So both of these are positive directions. And then negative velocity implies movement to the left or downwards. Okay, so negative velocity implies movement to the left or movement downwards. So it just depends on how we choose the orientation of the straight line, because we said this is motion in a straight line. So if we choose the straight line to be horizontal, then movement to the left is negative velocity, movement to the right is indicated by positive velocity. But if we choose the orientation of the straight line to be vertical, then this is positive movement and this is negative movement, meaning this is a positive velocity upwards, and this is negative velocity downwards. Alright, so for our example, what we're going to do is we already know where this velocity is 0. So we're just going to do a timeline, and then so when t equals 0, we know that v is 0 here, and then when t is equal to 4, we know that v is 0 there. So then this divides the timeline into two regions, this region here and this region here. So we just need to find out whether the velocity is positive here or negative, positive here or negative. Now, from the calculations that we did earlier, we already have determined the velocity after 1 second. We found that after 1 second, the velocity is negative 18. And we found the velocity after 5 seconds. We found that it is equal to 30 meters per second. So that tells us that in this interval here, the velocity is negative. So that means between time equal to 0 and time equals to 4, this object is moving to the left. Okay, and then here for times 4 and greater, this object is moving to the right. So it was moving like this. That means at this point here, the object changes direction. Okay, so that is that sorts out question D. Question E is looking for when the object is speeding up and when the object is slowing down. Now, the issue of speeding up or slowing down depends on the velocity and the acceleration. Okay, so if the signs of the velocity and acceleration agree, Okay, if the velocity and the acceleration signs agree, so that means either they are both positive or they are both negative, then we have speeding up. Okay, speeding up because they are working in the same direction. Now remember, acceleration is a force. So this is a bit like if something is moving to the left and then you apply a force to the left, then it's going to start moving faster and faster. So because acceleration is a force, so acceleration is a force, well, it's like a force actually. The force is acceleration times mass. So if you like, so acceleration is like a force. Then if the sign of the acceleration and velocity are contrary, okay, if the signs of v and at are opposite, so then we're going to have slowing down, because like I'm saying, is like your object is moving to the right and then you have got a force applied to the left, then you have got slowing down there. All right, so that means to answer the question E, we need to superimpose the sign diagram of the velocity over that one of the acceleration. The velocity we already have, so I'm going to put it here. So we say the velocity changes sign after 4 seconds. We say this side the velocity is negative, this side the velocity is positive. Then for the acceleration, if you set acceleration to be equal to 0, where is it? Here, if you set this to be equal to 0, that is going to be give us t equals to 2. So when t equals to 2, the acceleration is 0. So okay, so this is the velocity here. All right, so this is the velocity timeline here. So velocity, then gonna do the acceleration timeline. We have seen that the acceleration becomes 0 after 2 seconds. Now we've already seen that after 1 second the acceleration is negative. We worked it out here. So after 1 second it's negative 12. After 5 seconds it's positive. So that means it is negative before 2 seconds. So negative here, and then it is positive this side. So we are going to have regions here based on when each of these change sign. That's going to be the first region there, second region, and then the third region. Now remember, when the signs agree, we have got speeding up. When the signs are contradicting, we have slowing down. So here in this region, velocity is negative, acceleration is negative. So we've got speeding up. Okay, speeding up. Remember, when the velocity is negative, the particle is going to the left. Okay. Then in this second region, the velocity is still negative, but the acceleration is now positive. So that means the particle is now slowing down, but it's still going to the left. To the left. Okay. Then at 4 seconds, it changes direction because the velocity is now positive. So it's now going to the right. To the right. The velocity is positive. The acceleration is also positive. So that means it's now speeding up to the right. Okay. So that is sorting out question number E. The final question is requiring us to do a qualitative description of the motion of the object. Okay. Now this diagram is going to help us, and you can see that there are the first key time spot is 1 second, then 2 seconds, then 4 seconds, which divides the whole thing into 1, 2, 3 regions. In the first region, the particle is, so it starts off from rest, speeds up to the left, then after 2 seconds starts slowing down, then after a further 2 seconds it changes direction, then it starts speeding up to the right. So if you like, particle goes like this, then slows down, then after 4 seconds it changes direction, then it speeds up to the right. So speeds up and then starts slowing down, then speeds up to the, this is like 2 seconds, this is 4 seconds there, and then it goes on like that. So that's basically how this particle goes. Now we are going to put some more details so that our description can be more complete. So what we're going to do is at t equals to 0, we're going to work out the position of the particle by plugging t equals to 0 into the x formula, and that gives us 27 meters. The velocity at 0, we have already seen that it is 0 meters per second. Then after 2 seconds, the distance is 5 meters. The velocity at 2 seconds is minus 24 meters per second. T equals to 4. The displacement is minus 37 meters. The velocity is 0. That's when it's changing direction. Then I'm just going to do t is 5 here, which we've already done before. The displacement is now going to be minus 23, and the velocity is 30 meters per second. Now, so as far as this diagram is concerned, I'm just going to do a one-dimensional sketch of this. I think you'll see in a moment what I mean by one-dimensional. So like this. So this is the origin. So this is 0 meters here. Okay. So what this information is telling us is that at 0 seconds initially, the particle is located 27 meters to the right of the origin. Okay, so it's located say somewhere there. This is 27 meters. Okay, then the 27 meters, then it starts moving, speeding up to the left. Okay, so it starts from rest, starts moving up to the left. Okay, after 2 seconds, it is now located to the left hand side of the origin, 24 meters, which is this is it's 5 meters actually. So let's okay, so after 2 seconds is located 5 meters to the left of the origin. This is after 2 seconds, at which point it starts slowing down. So speeds up and then starts slowing down, and then after a further 2 seconds it is now at negative 37. So negative 37 meters here, and then at that point it changes direction and now starts moving to the right and accelerates all the way. Okay, so that's basically how that motion goes. I'm just going to show you now a diagram which is a distance time graph showing all the displacement graph, velocity graph, and the acceleration graph. Okay, all right, so this is now a graph. The red graph here is the displacement. So, and on the vertical we've got our x. So this is to the right and this is to the left of the origin. So the origin is here. So the particle starts off at 27 meters, then it goes down, it goes towards the origin. So that's the speed here. Okay, then goes past the origin at this point, which is this point here. Okay, then it is now in the negative distance to the left of the origin, and then after 4 seconds it changes direction, now moves back towards the origin, past the origin, and to the right. The green graph, which is obtained by the derivative of the red graph, is the velocity, and as I said, velocity starts off from 0. Now notice, so the value of the green graph is always going to correspond to the slope of the red graph. When the red graph is horizontal, the green graph is at 0. So even here it's horizontal, 0. When the red graph is negative slope, green graph is negative. Okay, the red graph is positive slope, the green graph is positive. So the velocity is negative all the way up to 4 seconds. Okay, so this velocity is becoming negative and bigger, so that's speeding up, and then now it goes towards 0, and then at 0 changes to positive, and it goes all the way. This is the acceleration here in gold. So again, all the points where the acceleration and the velocity have got the same sign. So here acceleration is negative, velocity is negative, so we've got speeding up. Here velocity is negative, but acceleration is already positive, so that's going to be slowing down. And then this side, velocity is positive, acceleration is positive. So from 4 onwards, we are going to have speeding up. All right. What we are going to do is we're going to ask you to have a go at this number 2 here. So have a go at this number 2, and then we will post another video where you can compare your answer to the answer that we're going to do. It's a very similar question. The only difference is the formula that gives the position is slightly different. Okay, thank you.